Okay, Unit 3, Day 6. We're nearing the end of Unit 3 already. Okay, so we're going to find the characteristics of the rational function, and then we're going to sketch it. So given the form and the numerator is linear, so it makes this a little bit easier. So the first thing I can do is find the y-intercept. So when you do that, you evaluate the function when x is equal to 0. So w of 0 is going to be equal to negative 80 over negative 5, which is 16. So my y-intercept is going to be 0, 16. So somewhere off my graph. I'll put it up here just for fun. Okay, so the next thing we can find is if we have a horizontal asymptote. So looking at my lead terms, my degree on the top is less than the degree on the bottom. So I have a horizontal asymptote at y equals 0. So I can go ahead and put that on there. Before I can do anything else, I'm going to have to factor. So the numerator, I believe I can factor out a 16. So w of x is equal to 16 times x minus 5. My denominator should be fairly easy to factor in my head because 3 is a prime number and so is 5. So I can use a 3x and an x. And then I need a negative 14 in the middle, and I have a negative 5. So I'm going to put the negative 5 there, and then my outside term is negative 15. And if I put the plus 1 there, then my inside term is 1x. So negative 15x plus 1x is my middle term, which is negative 14x. So automatically, I know I have a hole at x equals 5. So to find the y coordinate of that hole, remember we're going to ignore that term. So I now get w of 5 is equal to 16 over 3 times 5 is 15 plus 1 is 16. So 1. So I have a hole at the coordinate 5, 1. 1, 2, 3, 4, 5. So about right there. My x-intercepts, I have none because the one factor that would give me an x-intercept canceled. X can't be 5, so I'm not going to have an x-intercept. Plus, I have a horizontal asymptote, which kind of leads me to that idea, even though the graph can cross the horizontal asymptote. The other thing I need is my vertical asymptote, which comes from the denominator, x equals negative 1/3. If I have a horizontal asymptote or a vertical asymptote sitting in here, which also shows me that I can have a y-intercept very, very close to that vertical asymptote. The other thing I could do to challenge myself and not use a calculator would be go ahead and put that vertical asymptote into a sign chart. So if I choose a value less than negative 1/3, I can do negative 1 and positive 1, or how about 0? If I plug that into my factored equation, I'm going to get let's see, I'm going to get a negative on the top. Nope, I'm going to get a, yeah, so if I use my factored equation, my simplified one over here, that's going to be the easiest one to use. So if I put a negative 1 in there, well, my 16 is constant, so I get a positive 16 on the top. And then 3 times negative 1 plus 1 is negative. So that portion of the graph to the left of the vertical asymptote will be negative. If I put 0 in there, my 16 is constant, it's still positive. And I get a positive on the bottom, so I get positive. So I know my graph is going to look something like this. Negative to the left of the vertical asymptote, positive, and I have a y-intercept up there, so it's off a little bit. And it's going to look something like this. Pretty bad up there in that first quadrant, but you get the idea. All right, so next I'm going to do the same thing. I'm going to analyze. So first thing I do is look for my horizontal asymptote, which in this case is none. If I look at the top degree versus the bottom degree, that's going to give me the idea of a slant asymptote, because the degree on the top is 1 greater than the degree on the bottom. So I can calculate my y-intercept. So if I let x equal 0, I get negative 2 over 2, which is going to be 1. So I have a y-intercept here. I can go ahead and calculate my slants. And the way you do that is you take the numerator divided by the denominator, and you can use synthetic division for that. By the potential 0 of the denominator is 2. So my coefficients are 1, 1, negative 2. So I bring down my 1, I get a 2. Add, I get a 3. Add, I get a 4 here. So remember, this is your remainder. This makes no difference. This is my constant. This is x. So my slant asymptote is y equals x plus 3. So I have a y-intercept of 3. And if I go up 1 over 1, my slant asymptote is going to fit in here something like that. So now I need to factor. So my numerator is going to be x plus 2 times x minus 1 over x minus 2. So as far as wholes, I have none. There is no common factor on the top and the bottom. My x-intercepts come from my numerator. So I have negative 2, 0, and 1, 0. So I have an x-intercept there and an x-intercept there. And I've already calculated my y-intercepts. My vertical asymptote comes from my denominator. And in this case, x can't be 2, so I have a vertical asymptote at x equals 2. Which is going to be over here. So in this case, I probably wouldn't do a sign chart. I do know that my graph is going to go probably something like that. And then typically what happens in these, they kind of look like check marks. So I'm going to have the other piece of my graph up there. I could do a sign chart. It would be a little bit difficult, mainly because you wouldn't know it could possibly be there. 99% of the time that doesn't happen though. So on that one, you could stick it in your calculator and see what it looked like. All right, so there's your idea of a slant. Okay, so just to wrap up this graphing, we're going to find a function that could match this graph. So if I look at the graph, immediately I know I have vertical asymptotes at x equals negative 3 and x equals 5. So I know in my denominator I have to have factors that account for those things. I have a horizontal asymptote at y equals 0. That tells me that my numerator degree needs to be less than my denominator degree. I have a hole at x equals -1. So that tells me I need the common factor on the top and the bottom. My x-intercepts, I have none. And my y-intercept is sitting at 0, 1. All right, so let's put all that together and see if we can get this to work out. It's probably going to be my y-intercept that's going to give me a little bit of trouble. So just looking at my vertical asymptotes, my horizontal asymptote, and my hole. I know I needed x plus 3 in the bottom for my vertical. I need an x minus 5 for my other vertical. And for my hole, I need an x plus 1 in the top and the bottom. So now the issue is, does this work out for my y-intercept? So I need a 1 for my y value. Well, if you look at what you have now, if you plug in 0, on the top you get a 1, and on the bottom you get 3 times -5, -15 times 1, you get a -15. So that's not equal to my y-intercept of 1. But if I would multiply this by a -15, then this becomes a -15, and now it is equal to 1. So that fixes that problem right there. So typically you've got to look at that y-intercept and add a coefficient into the numerator to make sure that works. You can also check your horizontal asymptote on the top. You would have a -15x over x cubed. That works out as well for your horizontal asymptote. The degree on the top is less than the degree on the bottom. Okay, so one more. Here I have a horizontal asymptote at y equals 2. I don't know why that marker is showing up when I write. I have 2 vertical asymptotes. For my denominator, I've got one at x equals looks like -3. And I've got one at x equals 5. I have a hole at y equals 3. I'm thinking my horizontal asymptote is sitting there at 3, not at 2. I have x-intercepts. I got a lot of stuff going on this one. It appears to be -6, 0, and 2, 0. And I have a y-intercept. It looks like about, we're going to call it 2 just to make it a little bit easier. It's probably a little bit above 2, but we'll call it y equals 2. We'll check that when we get done. All right, so if I look at what I have, for my vertical asymptote, I need x plus 3 and x minus 5. For my x-intercepts, I know I need x plus 6 and x minus 2. For my whole, I need x minus 3 and x minus 3. This should be x equals 3, not y equals 3. So now I need to double check and make sure my horizontal asymptote is working and my y-intercept is working. So my horizontal asymptote is sitting at y equals 3, but if I look at all of my lead terms, I have x cubed over x cubed. So in order to get that to be y equals 3, I need a 3 on the top. So I'm going to add a 3 up there. So now let's look at my y-intercept and see how close I am to 2. Remember, it's not exactly 2. When I check my y-intercept with my function, I bet I can figure out exactly where that graph is crossing the y-axis. So on the top, I would have 3 times 6 times negative 2 times negative 3. Remember, I'm just plugging in 0 for x. On the bottom, I have 3 times negative 5 times negative 3. So that's going to give me, what do I got? 18 times 6, which is 108 over negative 15 times 3 over negative 15 times negative 3, 45. If I reduce that and divide by 9 at least, I can get 12 over 5, which is equal to 2 and 2/5, or 12/5. So looking at where this is crossing right there, that makes sense. So now I know this is equal to 12 over 5. All right, so that one was a little bit tougher. That y-intercept matched up, so we're good to go. All right, one more. Okay, analysis. I have a horizontal asymptote at y equals 2. I have a vertical asymptote. Pretty sure I have one going through here, just looking at my graph and that little twisty piece. So I must have one at x equals 0. And the other one sitting at x equals 3. I have I have a hole. Let's go ahead and write that. I have a hole at 5, 6, 7, 8. I have x-intercepts at 2, 0 and 5, 0. And I have no y-intercepts because of the vertical asymptote that sits at x equals 0. So we should be able to start writing this. My vertical asymptotes, I know I need an x on the bottom and an x minus 3. And for my whole, I need an x minus 8 and an x minus 8 on the top. For my x-intercepts, I know I need an x minus 2 and an x minus 5. So now I need to check my horizontal asymptote to make sure that's going to work. So if I look at the numerator, I have x times x times x. I have x to the third, and same thing on the bottom, I have an x to the third. That would give me a y-intercept of y equals 1. So I need to put a 2 on the top, and that'll give me 2x to the third over x to the third, or y equals 2. Also, no y-intercept. because for my y-intercept, x has to equal 0. And in this case, x can't equal 0, so I don't have to worry about that y-intercept. All right, so there you go. Have a great day.